Before we start, I would like to just go over a basic few house rules for the webinar. As you can see on the screen, please mute your micro while listening. Use the chat box for questions. There will be 2 Q&A sessions. Please also note that this webinar will be recorded. The slides and recording will be shared with you after the call. And also, if you could introduce yourself into the chat with your name, country, and organization you're calling from, that will help us facilitate afterwards to reach out to you in case there is a need. So restoration has gained a serious momentum the recent years, both on the international and national agendas. And to date, more than 210 million hectares of degraded forests and land have been pledged worldwide under the Bond Challenge, which is a main ongoing global forest landscape restoration initiative to bring at least 350 million hectares of degraded land and deforested landscape into restoration. Also, recent analysis conducted by IUCN in 2020 highlighted the importance given to restoration in terms of climate change adaptation and mitigation under the Paris Agreement. To date, up to 50 countries had integrated restoration interventions into the NDCs for approximately 57 million hectares. So it is crucial that all these pledges are turned into realistic action on the ground in order to strategically plan for forest landscape restoration. The restoration stakeholders need to be able to make informed decisions based on best available data, both ecological and socio-economic data. And as such, FAO has reached out to the International Institute for Sustainability, IIS, which is a not-for-profit organization which was first established in Rio de Janeiro, Brazil, with its first branch established in Australia in 2020. IIS aims to provide research capacity building and tools to inform planning and implementation of biodiversity conservation, climate change mitigation, land degradation, and associated sustainable development challenges. One of the main focuses of IIS Australia is to develop and build capacity tools for forest restoration and natural regeneration planning and implementation. So the planning for today is as follows. First, we have the honor to have with us today Dr. Robin Chasdon, who has more than 45 years of experience working on tropical forest ecology. She's a senior research associate with the IIS in Brazil and member of the IIS Australia, and also senior fellow with the World Resource Institute. Her presentation will focus on the potential of natural regeneration for FLR, as well as the importance of socio-economic context. This will be followed by a short Q&A session. And then we have the honor to have Brooke Williams, who is a research fellow at the IIS Australia, with extensive experience in development of decision support tools, who will present the Weplan-Forests decision support platform. This will be again followed by a question and answer session, and directly afterwards by an interactive poll and discussion session moderated by Blaise Baudin from CBD. We then will close for today. Once again, please put in your chat the questions during the presentations, and also let us know where you're coming from, which country in this institution. It is now my pleasure to invite Blaise Baudin to say a few words on behalf of CBD. Thank you.
Good morning, everyone, and thank you, Benjamin, for the introduction. I'll be brief with my remarks. It's just to say that the CBD Secretariat of the Convention on Biological Diversity has this program called the Forest Ecosystem Restoration Initiative, and this Forest Ecosystem Restoration Initiative is funded by the Korea Forest Service of the Republic of Korea. And so we're very thankful for that funding that helped us to provide support, technical support on restoration to a number of countries around the world, and also to develop these decision support tools, such as the one that will be presented today by Brooke. And this has been at the center of our efforts to help countries plan for restoration in a spatially explicit manner and optimize the benefits of restoration, and also think about the levels of ambition for their restoration targets, especially as they will prepare for to set out new targets under the revised global biodiversity framework that is expected to be adopted later this year. And so we're very grateful for the opportunity to provided by FAO to present this tool, because we want to put it out not just for CBD focal points, but for any governmental or non-governmental organization that is wanting to plan for restoration and for its benefits. So we're excited about this session, and thank thanks everyone for your presence, and thanks again to Korea Forest Service for the support.
Thank you, Blaise. So I would like to invite now Dr. Sheldon to take the first presentation.
Okay. Hello, good morning, good evening, good afternoon to everyone. It's a great pleasure to be here today to introduce to you the topic of natural regeneration, why it's important, and why it's important to assess its potential when thinking about implementing forest landscape restoration. First, I want to bring out the importance of understanding the ultimate objective of restoration, because restoration is really the means for achieving many goals. And whether you're doing ecological restoration or ecosystem restoration or forest and landscape restoration, one fundamental aspect is that the interventions that are undertaken are designed to prevent, halt, and reverse degradation and to assist the recovery, either of the ecosystem or the ecological functions within the landscape. And when we're thinking about this aspect, the question we need to ask is, then what do we need to do to assist the recovery and to prevent and reverse degradation? And I would like to suggest that in some cases, we really have to do very little. All we need to do is provide nature with an opportunity to recover ecosystems on their own. And this can happen within the broader landscape context. This is a 32-year-old forest that in 1982 was a pasture and a farm, a few cows, a small house, a family living there. And in 1985, the area became part of a protected zone of a national park and a biological station in Costa Rica. And the family was relocated, and very quickly thereafter, the forest just began doing its thing, doing what it's meant to do. And when it was 12 years old, we set up a research plot in this area. So we've been following all of the trees coming in and going out since then. So I've become very familiar with this forest, and it has shown us, and along with many of our other study areas, including people doing research in many parts of the world, that some forests in some places can restore themselves. But it's important that the drivers of degradation are removed or halted in order to allow this process to continue. So I think it's another question to address whether an entire landscape can restore itself. I think that's a much more challenging prospect. So what I'm going to present today is really about patches of forest within a landscape, and understanding which of those patches and where might be able to undertake the restoration using their own abilities without requiring very much human assistance. And the value of this is one that we can focus our efforts, our financial efforts, and other technical efforts on restoring forests in areas where they will not restore themselves and where they really do need our help more actively. So we can more effectively allocate the limited funds and attention that we have, and basically just allow forests to recover where they can on their own. There are many different strategies for forest restoration. So what I'm discussing today is really just this one aspect where the forests are allowed to regrow on their own. But within a forest and landscape restoration context, we have multiple interventions that can all be conducted within the landscape and can complement each other. And that's a very important aspect to consider. So why is this important? There are many ecological and social benefits of natural regeneration. And one is that multiple ecosystem functions can recover at the same time or in concert with each other over time. And this forest recovery supports local knowledge and cultural practices that are based on diverse uses of native flora and fauna. These are species that are often very well known to people and very important in their daily lives. It builds on the ecological memory in the landscape and also can enhance the ecological memory in the landscape. And it also creates forests that have potential for management and enhancement in many ways. So it is not an endpoint in itself, it is basically a starting point. And of course, because nature is doing most of the work, the birds are bringing in the seeds and planting them, and the bats, the costs of implementation are much lower. Now, natural regeneration is very dependent on the local climate and ecological conditions. And we have conducted a global study that looks at how the rate of natural variation varies around the world and how this affects the amount of carbon that can be stored during those initial 30 years. And this map just shows the wide range of variation, 100-fold level of variation in the rates of above ground carbon storage during natural regeneration. So it doesn't have the same properties everywhere as far as carbon storage goes. And it's important to realize this, but now that we have this information, we can also look in those areas where forests no longer exist and where we could use this information to not only identify areas where forests could regrow naturally, but also understand what their potential for carbon storage might be. So we can have a much more refined expectation of what the outcomes would be for carbon storage. In a study that was conducted recently in Brazil's Atlantic forest by Cruzelis et al., there was an analysis of how much forest regrew on its own through natural regeneration over this 20-year period, from 1996 to 2015, using Mapa Biomas data. And that study identified areas that recovered forest cover, but not through planted forests. These were not planted, these were forests that came up on their own. The study showed that over 2.7 million hectares of forest regrew based on natural regeneration. And this close-up in this inset shows the green areas or existing forest patches, which are scattered all over the Atlantic forest in great numbers. And in these cases, the brown areas were the regenerating areas. Many of them tend to be adjacent to or very close to these fragments. We then did a spatial analysis of what were the predicted variables, what variables best predicted those locations where natural regeneration did occur. And that analysis showed that the largest contributing factor was being very close to an existing fragment of forest. So 90% of the cases, the regenerating forests were 192 meters, within 192 meters of a forest. So this highlights many aspects that we can immediately apply to restoration planning. And if these cows were removed from this area, it is likely that you would see a lot of natural regeneration happening here within a fairly short time frame. So we use this information to predict where within the Atlantic forest there was a moderate to high capacity for natural regeneration. And where there was an intermediate capacity, we tagged those areas as potential sites for assisted natural regeneration, where certain obstacles still needed to be removed. And our analysis showed that within the next 20 years, assuming that conditions remain similar to the previous 20 years, 2.8 million hectares could regenerate naturally with very little or no interventions. And close to 19 million hectares could be restored using assisted regeneration methods. And this would have an enormous effect on reducing the costs of restoration in the entire Atlantic forest, as you can imagine. And this is the map that our project produced, in that it showed very where in the Atlantic forest. In the blue, we could likely have interventions based on assisted natural regeneration, where active regeneration or restoration methods using tree planting of nursery grown seedlings would be required at a substantially higher cost, and where the existing forest remnants are in green. So this is an example of how using the knowledge of natural regeneration potential can be used for restoration planning at a very large scale. Now, we can also do this at the global scale. We're beginning to understand what the total opportunity is for restoration on already converted areas within forest biomes. So these are the areas indicated in green on the map. Forests used to be there and they're no longer there. And in this study by Strasberg et al., we looked at the global potential for all kinds of restoration of including non-forest ecosystems. But here I'm just going to focus on the forest ecosystems. We tried to look at what the global potential would be for natural regeneration globally across the tropics and the subtropical regions. And this study is, please don't tweet about this because it's still in preparation. But we worked together with Matt Fagan and his group to do an analysis similar to what was done in the Atlantic forest, looking in the past, where natural regeneration occurred. And then we projected out in the future based on predictive variables. And our analysis showed that over the period between 2000 and 2016, a total of over 5 million hectares of forest regenerated naturally globally. Obviously, a lot of that was in Brazil. And this is compared to over 11 million hectares of plantations globally. So double that number was new tree cover in plantations as opposed to naturally regenerated areas. Then we looked at which variables were the best predictors. And again, here we're using data from a variety of different climate zones. So we found, in addition to the local density of forest and the distance to the nearest forest, there were some climatic variables that were also important, and soils variables. So based on those predictive variables, we then took the step of predicting where globally there was a high potential for natural regeneration. And we found a huge potential globally, over 300 million hectares globally. And most of those are distributed all across the world's tropical regions, as you can see here. The largest area of potential is in the neotropics. And we looked at the top 10 countries here, just so you can get some idea of what is the biophysical potential. So the variables that we're using here to model predictive potential are only based on biophysical parameters. And we see Indonesia also very high, in addition to Brazil. Also, many regions of China have a high potential capacity. And in Latin America, Colombia and Mexico, and in Asia, we have Vietnam. There's also a high potential in the Democratic Republic of Congo, and then in these Asian countries as well. So with this information, though, we know that only 5 million hectares actually showed natural regeneration in the past 16 years, compared to the potential, that the main limitations to natural regeneration are not so much biophysical, but they're mostly socioeconomic. So the conditions for natural regeneration really require a lot of support and particular kinds of socioeconomic contexts to really favor this approach to forest restoration. Yet I think with this information, we know that we can leverage this potential to really enhance and favor large-scale forest restoration in landscapes throughout the tropics. So I'll just wrap up with these 3 messages. First, that in many cases, we know that forests can restore themselves with little or no human assistance. It's important to understand the context in which that is happening, and then use that to inform decision support tools, which can help to predict areas that more likely will happen based on these predictors. Second, the main limitations to natural regeneration are not biophysical, but they're socioeconomic. And these aspects must be incorporated into understanding landscape scale planning and implementation, because they're also likely to affect other forms of restoration and not just natural regeneration. And third, that planning and implementing forest and landscape restoration can leverage this potential for natural regeneration to reduce the overall costs and enhance ultimately the benefits for biodiversity and the other benefits that I mentioned. So thank you very much. And now I can take some of your questions.
Thank you, Robin, for this eye-opening presentation on the huge potential of natural regeneration, and also the importance of really considering the socioeconomic factors driving degradation in the landscape. So the floor is open for everyone to raise their questions. You can all write in the chat or put your hand up or put your video on. You can intervene directly. The floor is open. At the moment, I don't see any question in the chat. Maybe I missed some. No.
Mathilde.
Yeah, I'm trying to raise my hand. Sorry.
Okay. Please go ahead, Mathilde.
Thank you very much, Robin, for this very interesting presentation. I have a question about, you said on the map, you identified some area, and quite a large area actually in Brazil, that was that already underwent natural regeneration. So in this area, what were the conditions that were put together so that this happened? Do you know if this area were fenced? What happened so that this happened?
Our analysis suggested that the most important thing is these were on the edge, very close to existing forest fragments. So these were on, including, most of this was on private land. So these, having forest fragments on private farms, often on the tops of hills or in riparian areas, is huge, because these would be the areas where it's likely that natural regeneration would have happened. So some of these could be on large farms where the cattle preferred to be in lower areas and were not on slopes, and the slopes is where the forest fragments were, and this is where regeneration happened. So, I mean, that's not every scenario, but these tend to be less accessible areas, we think also, and they may be areas that are not as carefully monitored by the farmer.
And I'm sorry, can I have a follow-up question? I was wondering, like, did you also compare like which area were degraded at the same time? Did you see if like some were left alone to regenerate while some other were actually more degraded?
The analysis that we did was simply based on remote sensing evidence of tree cover gain. So it was sustained tree cover gain that we looked at, not just 1 year. But we didn't have information on the state of degradation initially. So we weren't able to really assess that. It has certainly been studied in other contexts. And we know very well that the more degraded the land is, the more obstacles there are to the recovery process. So there would be more interventions needed to assist the regeneration in those cases. But in our study, we weren't able to really identify what those degradation factors were.
Thank you, Robin. I've got a question from James Dufa. Please go ahead.
Yes, thank you. Robin, it's nice to see you again after the ROM training. My question is, I think that was a very nice presentation. You have rightly said that you need remnants of forest to allow the natural regeneration. Have you worked on how much do they have to be close areas where you need to regenerate, or they need to be in some areas in Africa where we have people clear large pieces of land, and that will really depend on the seed bank, whether there is some seed
Yes.
existing in the soil for it to regenerate. Have you looked at some of those factors?
In many studies have looked at the seed bank, and it tends to be pretty short-lived in tropical regions. So it's very much dependent on the existing vegetation providing seed into into the soil. We don't know exactly what this sort of threshold is for either the quality or the quantity of forest that is required. Again, this is going to be very context dependent. Some studies have been looking at this factor in more detail within a particular region. In some cases, the prior land use is more important. In other cases, the landscape context and forest cover in the surrounding area is more important. So both of these can be important obstacles to natural regeneration, because the site could be very degraded, there could be lack of seed. But if there are no trees in the surrounding landscape, there are also lack of seed. And there could be lack of dispersal if there's been extinction of many of the seed dispersing animals as well. So these are all factors which are important to consider, and the relative importance of the sort of internal site versus external site factors are probably going to be very dependent on the context and the history of deforestation and the spatial patterning and what kind of land uses are in the region. So I don't think there's a single answer for that.
Okay. Have you also looked at in terms of biodiversity, looked at what species are regenerating on the open piece of land as compared to those species which are in the patches? And have you done any comparison between the two?
Yes, many people have been doing this kind of research, there's sort of good news and there's not so good news in terms of what's coming up. We have in the sites in Costa Rica, like the one here, we're seeing just a big influx of species, including species that you find in older patches of forest. In some areas which are more isolated and where there isn't as much forest cover, the species composition is going to be quite different than what you find in a mature forest. So there may be a need to enrich the composition or add some seeds or add some seedlings over time if they're not coming into the site. It doesn't mean that you should ignore natural regeneration. It just means that it may just be one of the things in the toolbox, and that after monitoring over a few years, enrichment planting could be conducted in that site. So I think there are mixed approaches as well that can be used.
Thank you, Robin. I think there's also a link to another question we had from Elijah Mboko. He had actually two questions. The first one is, how well do we manage to deal with the challenges of community interfering with the natural resources? And how best do we decide on where to apply natural regeneration and where to assisted natural regeneration will be used?
So yes, it's very important, especially in the early stages of natural regeneration, to not go in the site and do a lot of destructive harvesting or activities, because that will really set back the process. Once the regeneration is underway, there can certainly be activities going on in the site, selective harvesting or enrichment planting or management. Even converting the site to more of an agroforestry system is possible. So that's what I meant by saying it's very open-ended, but you don't want to initially prevent continued degrading the site so that you're just creating more obstacles to regeneration. The same applies to a planted site as well. You need to give it time and take care of it very much during the early stages until the trees are growing, until you got rid of the grass or the invasive species, whatever the obstacles are. So obviously you need to continue to do monitoring and keep track of what's happening and avoid a further degradation in that process. I forgot what the second question was, I'm sorry.
How to decide on assisted natural regeneration and natural regeneration?
Yeah, so this really has to do, and And in a recent paper, we've just begun to do like a decision tree on this. But I think part of this is really having an understanding of what are the main obstacles to natural recovery. And if there aren't very many, and you may discover that simply leaving the area alone, you may not even have to make a fence. Sometimes you have to make a fence. Sometimes you have to make a fire break and make sure that fires that are being set and farms nearby don't get to the forest. And so there are some rules that we can follow, but it's also very context dependent. And often, even in some cases, having some cattle in the area can actually help forest restoration in some contexts, because they are dispersing seeds and also eating grass that may be an obstacle. So there's again, it's really a question of understanding what are the main obstacles in the way of the natural colonization and establishment of species, and doing what you can to remove those obstacles and enhance the recovery.
Okay, thank you, Robin. I think we need to move ahead and go to the other presentation. Any other questions that come up, you can also answer after the second presentation. So thanks again, Robin, and for your questions. Can I ask Brooke to take the floor for the next presentation?
Brooke, you're muted.
How's that? Can you hear me and see my screen?
Please go, yes, presentation mode.
Great. So hi everyone, I'm Brooke and I work with IIS Australia. So I'm really excited to present to you today Weplan-Forests. So there was a lot of us involved in the development. So thank you to everybody involved. So hopefully I can show you a bit of what's under the hood. But I'm going to start with a bit of basic background information. And if this is already if some people already know a lot about spatial planning, this will be irrelevant. So sorry, but I think it's useful to kind of just give that little bit of background information. So Weplan-Forests is an optimization problem. So what is an optimization problem? We're optimizing our decisions every single day. Oops, sorry, I'm trying to minimize this. I wonder if I can. I'll just leave it. Okay, so every day we're optimizing our decisions. For example, if I go to the grocery store and I have $10 to spend, I want to get the best value for money that I possibly can. So I want to maximize the amount of food that I'm buying. I want to maximize how good it tastes. I want to maximize its nutritional value, but I'm constrained by how much money I have. So I only have $10 to spend. So the purpose of an optimization problem is to achieve the best possible design or answer relative to a set of prioritized constraints. So we're going to walk through a really simple restoration spatial planning problem. So in this situation, we're restoring a coastal habitat, as you can see to the left here. So first we have to divide our spatial region into planning units. So planning units are the blocks that make up a spatial planning analysis. They're the jigsaw pieces that correspond to actual areas on Earth, and they represent the values inside of those areas. So the things that we care about, we can quantify them within planning units. So in this situation, can I minimize this? Sorry, I'm not sure how to get rid of that. I'll just make this smaller. Does anyone know how I can minimize? Can I make this smaller?
It was fine before, Brooke. I don't know.
Oh, it was fine before. It's just blocking me. Okay, so in this spatial planning exercise, our objective is to ensure that one of each species is within our restoration area. So we want to capture the most amount of, so one of each species in our restoration area for the least cost. So it's a very simple planning problem. Each planning unit, A, B, C, D, E, F, G, costs about $10,000. And we just need one of each species in our restoration area. So I'm going to give everybody 5 seconds to select which planning units meet our objective of one species for the least cost. Okay, so initially you might think that A, B, and C is the best answer because planning unit A, as you can see here, it has the most species. So obviously we want to get planning unit A, right? But if we choose planning unit A, then we also need to include planning unit B and C to get the turtle and the shark. So our restoration plan costs a total of $30,000. But if we were to restore planning units C and E, then we meet our objective of one of every species. We've got the turtle and the shark, one of everything else, for only $20,000. So that's the answer to our optimization problem. That's the least cost for getting one of each species. So I've shown you a super simple optimization problem with just 7 planning units. But what if there was 1 million? And what if there was more than one question to answer, more than one objective? And what if you needed to constrain that problem by a budget, for example? So as you can see, the restoration problem gets super complicated super fast. And many decisions are high dimensional. And for this reason, we need formal mathematical methods to identify good alternative solutions. So the human brain is excellent at many things, but identifying solutions to high dimensional problems is not one of them. Also, as Robin mentioned, resources available for conservation and management actions are usually limited, and therefore it's really, really important that decisions about where and when to implement actions are undertaken as efficiently as possible. Also, restoring in the wrong place can lead to wasting your money, the project failing, you could not meet your objectives, you could lose on biodiversity and ecosystem service values. So for this reason, we've developed Weplan-Forests. So its purpose is to provide a spatially explicit planning support for forest restoration activities to assist nations in achieving their restoration goals. Specifically, it addresses the problem of cost-effectively maximizing ecosystem service benefits for forest restoration in order to support target setting and policy development. The key outputs, I'll explain that in more detail in a minute, but the key outputs are the estimates of possible climate change mitigation and biodiversity conservation benefits that could be achieved through forest restoration, the opportunity and establishment costs associated with various levels of restoration. It quantifies the trade-offs or the relationships among objectives in order to identify those good compromise solutions. It provides spatially explicit maps of priority areas for restoration to support decisions. And it's a transparent, objective, repeatable, and evidence-based assessment. So this is just a framework, a conceptual model of our optimization framework. So on the left-hand side, we have all of those things that we care about. We have species, we have carbon sequestration potential, and we have cost. So we have our opportunity and establishment costs, which are influenced by the potential for natural regeneration, which is critical, as Robin mentioned in her talk. So we haven't, with the Weplan version that's online, the potential for natural regeneration hasn't been included, but it will be in the soon to be updated version 2, which will be out soon. But you take all of these things that we care about and we run them through our optimization model. And these elements, these benefits are influenced by restoration targets or subject to restoration targets. So we need to define how much we want to restore for each study region or country in this case. And we have to define relative priority weightings for biodiversity and carbon objectives, how much we care about those things. And by manipulating those weights, that's how we get the trade-off curves between both of those objectives. The outputs from Weplan-Forests come in the form of priority area maps and trade-off curves. So priority areas for restoration. So I'm just going to run through each of the data sets, and then I'll explain the results a little bit more. So for a climate change mitigation potential, we used a model that was developed by a colleague of ours at the University of Florida, Evan Broadbent, and it estimates the potential for carbon sequestration in above ground biomass following forest restoration. So yes, very grateful to him to have developed a wonderful model for us to estimate that potential. For species, we use thousands of species distribution models for amphibians, birds, mammals, and reptiles and plants. And we use the Spark database, which you're more than welcome to have a look in online in a little bit more detail. But it uses species distribution models representing the ecological and climate niche. And basically we quantify biodiversity benefits in Weplan-Forests as an extinction risk model, which is a species area relationship based on the remaining habitat area. So for costs, we incorporate opportunity and establishment costs. So opportunity cost represents foregone agricultural benefits. And we incorporate opportunity costs so that our restoration priority areas reduce the conflict between forest restoration and food production and the provision of livelihoods to landowners and local communities. So establishment cost represents the variation in tree planting costs across different nations. And again, we have some more updates to this data coming in version 2. So we are excited to improve on these cost models. So we also only restore, as Robin mentioned, areas that have been converted, so converted lands. So that's essentially our study area. And I'm just using throughout this presentation the example of the DRC. And these are the areas available for restoration as this definition of converted land. And so we exclude obviously already forested areas and areas that won't be restored, like urban centers and things like that. Okay, so this is an overview of our scenarios and our targets that we evaluate. So we evaluate 80 scenarios in total, which are all available to everybody online. But we evaluate a maximum benefit scenario. So that is the maximum benefits of biodiversity conservation and climate change mitigation that can be achieved through restoration. So it's ignoring costs. We just want to maximize those two things that we care about. Then we have a cost effectiveness scenario where we include within our suite of scenarios, which I'll explain in a minute, cost, opportunity, and establishment cost. Then we also evaluate a minimum cost scenario. So what if I wanted to achieve my targets for the least possible cost? And a random scenario, which represents what if there was no planning at all and we were just restoring without spatial planning. So I'll show you what these look like. I'm going to walk us through an example. So this is a trade-off curve. This is how we can see the benefits for biodiversity, carbon, and cost for each of our scenarios, each of our spatially explicit solutions. So in this example, we're restoring 30% of the area available for restoration in the DRC, or approximately 2.5 million hectares. So let's say we cared only about biodiversity conservation. We want the map that shows us where we can restore these areas for the maximum possible benefits, the highest value on this y-axis for biodiversity conservation. So we can see that's what our spatial solution would look like if that's all we cared about. So let's do the same for carbon. I only care about carbon. I just want to restore my 2.5 million hectares to get the maximum possible carbon benefit. That's what my restoration solution would look like. So you can see each of these points on the trade-off curve represents a spatially explicit solution or map. And by adjusting how much we care about biodiversity, conservation, and carbon, we get the suite of solutions that balances those two objectives. And we can see how much these solutions cost by the colors. So red is very expensive and purple is very cheap. So this is that maximum benefit situation I was talking about. We are ignoring costs here and only looking at biodiversity and carbon. In this second trade-off curve, we bring in cost. Okay, we also want to make our solutions cost effective. How can we minimize the cost of these solutions? So that's what our answers look like. I'm going to show a solution which balances, perhaps we want to balance biodiversity, conservation benefits, carbon benefits, and cost effectiveness. Our solution would look like this. And we can tell that it's a compromise solution because it's not at either end, it's somewhere in the middle. So we can also quantify the percentage loss in biodiversity value and carbon value that we're missing out on, but it's a compromise. So generally, the patterns among scenarios for each country are very similar. We found that it's not possible to achieve maximum returns on all objectives simultaneously. So you can't have the best possible outcome for biodiversity at the same time as having the best possible outcome for climate change mitigation. They're in different places. So that's why it's super important to evaluate the relationship between the two to identify those compromises, to find the balances. The cost effectiveness scenarios, that second trade-off plot, typically achieve lower benefits. As you can see, there's lower values for biodiversity conservation and climate change mitigation compared to the maximum benefit scenario. But they're more cost effective and have a higher return on investment. So the maximum benefit scenarios in comparison are typically very costly. So you can see those points are in the red, the cost effectiveness solutions are much cheaper. The minimum cost scenarios, those scenarios that minimize costs as much as possible, are super cheap, but they typically provide lower benefits. So the minimum cost is always worse for biodiversity conservation and climate change mitigation compared to planning. And of course, the random solution is more expensive than even the minimum cost, scenario, than many other scenarios, and it does terribly for biodiversity conservation and climate change mitigation. So you can really see how spatial planning just really maximizes those benefits and why it's so important to make sure that you're planning your restoration activities. So Weplan-Forests is online now. You can visit it here at this website. So it's got all of the targets that we've evaluated, all of those trade-off curves. There's all of the spatially explicit solutions, the maps to each of these scenarios. So you can click on each point and see the map. And it has the exact value for each point in the table. That's available all on Weplan-Forests. So feel free to log on and have a look and yeah, see what you think. Also, we have country reports available, so PDFs are available for each country that we've evaluated to download. So the idea is that this is a summary of everything for each country. It's got very extensive methods described, and bits and pieces can be used for various reporting purposes for in-country policy making, or basically for any decision makers' needs. If they want to take a particular target level, use those results for something that it's all easily accessible and downloadable. So obviously I have presented Weplan-Forests as a global optimization framework, but there's many things that we haven't yet accounted for. So we're going to release version 2 soon. We're going to be continuously updating and improving Weplan-Forests. But particularly, we're very interested in the next stage, which is implementation. How can Weplan-Forests be taken on the ground? And this, of course, will need to account for many other factors. So things like job creation, forest production, agricultural output at that more regional, local, or even national level scale. So we're, more than happy to discuss with anybody who's interested, who thinks Weplan might be able to help them achieve their restoration goals, to discuss further on how Weplan can be customized for them. So yeah, that's basically it, and feel free to reach out to anybody, and we're more than happy to discuss further. So thank you so much for listening, and looking forward to the discussion.
Thank you very much, Brooke, to make complexity look a little bit simpler. We already got some questions in the chat. I don't know if first one, Mathilde, you want to raise the question yourself?
Yeah, I mean, I was just wondering, so you were saying that there was this the biodiversity impacts and climate impacts where there was a strong trade-off between the two. And I was wondering why. Is it because, like, if you really want to be climate efficient, you need to do kind of monoculture of certain species? Why is there such a trade-off?
So it's the carbon model is the potential for carbon sequestration, right? So the potential that you can gain by restoring an area. So of course, sometimes those areas line up, and the areas with high potential might be might be habitat. Obviously, it's probably not current good habitat for species, but it might potentially be good habitat for species once restored. But in general, the areas are quite different. The reason for that, that's a good question. So the carbon model, it's based on biophysical variables such as climatic conditions and other physical variables across Earth in the forest biome. So yeah, that's, I guess, in sometimes they do line up, but in general, you can't explicitly solve that problem of 100% maximizing biodiversity and 100% maximizing carbon benefits and having them intersect. So although they do intersect in some cases, in general, you really need to consider both objectives to find the places that they do intersect, those compromises.
Thank you.
Okay, we've got a question from Lisa. Lisa, will you want to raise it in plenary?
Sorry, did you want me to voice the question?
Yes, because it's quite long.
Okay, so it was just going back to the very simple scenario presented before, or the detailed analysis about the the 7 situations where you are simply choosing which areas to restore in order to get as many species as possible. And if you are, I'm wondering, because there was a difference in cost between 20,000 and 30,000, and then if you're doubly doubling up on some of the species, is that $10,000 difference, do you think it's adequately representing the benefits that might be accrued from doubly restoring species? And
Right,
of course,
so-
we know that there's lots of caveats with the tool. So, and you have to be aware of these when you're applying it. So it might be worth it. What I'm wondering is, it might be worth the 10,000 to doubly restore some species.
Yeah, so in that very simple one, so I wasn't sure if you could see the problem as it was written, because for me it was covered, but the objective of that simple optimization problem was just one of each species for the minimum cost. So in order to meet that objective of just one of each species, you could do it cheaper. The optimal solution was the 20,001. But if you did change your objective to maximizing biodiversity value, balancing it off with cost, that's a different optimization question. So in the case of Weplan, yeah, you're absolutely right. That's exactly the compromise question. So the 100% maximum biodiversity benefit is on that left-hand side of the plot. And then when you start accounting for other objectives like cost and climate change benefits, carbon sequestration potential, then you miss out. You have to reduce your biodiversity value a little bit. So Weplan doesn't say, this is where you should go, this is the best answer to restore. It's just solutions to help the decision makers decide. So decision makers are obviously going to have different objectives, and it's about, they need to consider what's important to them and then balance those things together. Is it biodiversity? Is it carbon? Is it both at the same time? Is it maybe a little bit more than biodiversity than carbon? So it's not about, yeah, so I guess that's the point of Weplan. It's super complex. There's a lot of different things we're considering. It's up to the decision maker to decide which of those scenarios is relevant for their country, for their situation, and to evaluate how much biodiversity loss they're willing to accept in order to gain a little bit on cost savings or carbon. So that's exactly why the trade-off curves are so crucial.
Thank you, Brooke. We've got maybe one more last question before going to the polls. Is from Meshach. Meshach, you want to raise a question?
Yeah, thanks, Benjamin. Yeah, my question was that if you were to evaluate this, especially do an evaluation, for example, Kenya, how much would that cost? What would be the minimum cost for doing this?
Minimum implementation cost for restoration? Or is that what your question is getting at?
You want to ask for the minimum cost of doing the evaluation itself, but you have done the evaluation already for Kenya. It's already online, no? The national level one?
Yes, that's right. It's already freely available online. So yeah, all solutions we focused on tropical countries with tropical forests with to restore, but Kenya is in there.
Yeah, if I may,
yes,
if I may just complement Brooke's answer, if Meshach, if you mean doing like a customized version, changing something in the models we already have, because we have a defined set of parameters that you might want to change because your country's objectives may be different from what we started with, then we would advise that you contact us. You can email me or Brooke, and we can talk about it, because the cost then would depend a lot on what we have to do. You know, what is the different thing that you want to do with this platform? Thank you.
Thank you, well guided.
Thank you, Marina and Brooke. Yeah, because another question linked to that, can countries customize the platform using their own data and additional data? But I think you already answered that question. Blaise has got a question.
No, it's just a follow-up point on that issue of the customization, and just to add that we're going to continue as part of the CBD Ferry, continue this collaboration with IIS this year, and our aim really is to ensure that this is used for decision making by CBD parties, which Kenya is one. So. Yeah, there's an opportunity to get further support for the application of this tool. With the platform, really, our aim has been to make this data available readily for partners, so they can just go on the platform and download the data. But we understand that many countries will require some little bit more of hand holding to integrate that data in their decision making process, and we're ready to provide that support together with IIS. So there would need to be like some sort of formal request, ideally from the CBD focal point, if there is interest in developing a customized version of the tool, or just applying it to a specific policy question in a given national context.
Thank you, Blaise. And maybe we can immediately go over to the next session, to the polls.
Yep.
If you would like to moderate that.
So I'll moderate that session on the poll. So you should be seeing a list of choices on your screen now. And the first question is pretty easy. It's just for us to get a better understanding of the audience today. So if you could just tell us from which of these stakeholder groups you belong to. Katerina, is the poll open?
Yeah,
Yes.
it's there.
Yes,
Yeah.
the poll is open.
Okay.
People are voting. We have 59% of the people voted. So if everyone can vote.
All right, so thanks for your answers. We don't get to see the answers live, right?
Maybe at the end.
Okay. So the next question would be about the type of information that would be most relevant for your decision-making process on forest ecosystem restoration. So as Brooke mentioned, we're constantly working on updates to the platform and to its user interface. So it's useful for us to know like which ways of displaying the results are easier to understand for you, or most usable. So from that list, if you could pick, one type of way of presenting the results that is most useful in your understanding. So could either be graphs comparing quantitative estimates of benefits and costs between scenarios, or maps identifying priority areas, or quantitative estimate of the biodiversity benefits of forest ecosystem restoration, or of climate change, or estimate of costs, or finally this idea of trade-off curves, illustrating the relationship between different objectives. So thanks for your answer. And our next question is with regards to so it's actually a question about questions. So we're wondering, in your policy processes, which of these following questions is the most relevant? So we're trying to understand, what's in your head when you try to plan for restoration. What are the questions that we can best help you with? So from that list of questions, if you can pick the one that's closest to challenges you're encountering right now in planning for restoration at the national level. So is it about trade-offs between benefits and costs? Is it about benefits, etc.? I'm not going to read all the questions because I think it might just interfere actually with your own reading. So I'll let you read the list of questions and pick which one is the closest to your current thinking. And this time we are seeing the results. We can see that the question that was voted most relevant is what type of restoration interventions should be implemented. So that's interesting because it links to our efforts in that platform to integrate that that aspect of natural regeneration that that Robin presented on, and this is where we want to go. I cannot say that we can already fully answer that question with the tool, but it can certainly give some indications based on the type of benefits that can be expected, and also based on that assessment of the likelihood of natural regeneration in a given area. So, and then the next, yeah, we can move to the next question. I guess we're pressed with time a little bit. So the next question we have is whether the natural forest regeneration potential has been assessed in your country, and whether it's been assessed at national scale or locally, or whether the assessment is in progress, or if it's planned but has not started, or if this issue has not even been considered. So just to make sure everyone understands correctly, so this is about not the restoration potential as in general, but really about natural forest regeneration potential. So the capacity of the forest to regenerate on itself, not just the fact that it's degraded and needs to be restored. Okay, so we can see that in most cases, this has been done, but only at the local level, and that's interesting because we hope that really the tool that we're putting out here is going to help you do this at the global level, at the national scale, but we have these global data sets, but that you can look at the national scale. And we hope that this can help accelerate these assessments where they're in progress or are being planned. All right, so the next question we have is on the benefits of restoration, and we're asking here to think about these benefits in terms of economic value in your national context, so or subnational context. And so from that list of benefits, which one is likely to have the highest economic value for you? So is it carbon sequestration, biodiversity conservation, hydrological services, or erosion control, benefits to agriculture, employment, or some other benefit that we didn't think about? Oh, that's interesting. That was unexpected to me, at least. That biodiversity conservation is the one expected to have the highest economic value. I'd be really interested to know actually how you will. I mean, I definitely this is a high benefit, but it's often hard to financially realize. Unless you have a national park and you can get financial income from visitors or things like this. But it's really interesting to see that this remains a top priority for this audience. Finally, this question that we have is about the obstacles to forest restoration in your country. So we're interested in knowing, like, what are the hurdles at this time for you to implement restoration, Is it more because of a lack of funding? Is it more because of the capacity of implementing agencies that don't know enough about restoration? Is it, do you feel like it's a lack of political will essentially, or shortcomings of the legal or regulatory framework? Or is there a lack of engagement or opposition from certain stakeholders to the very idea of restoration? Okay, so that's interesting. We can see that there's, there's a tie here in the answers between the lack of funding and the lack of engagement or opposition from certain stakeholders, which is probably related to the lack of funding as well. And yeah, that's interesting for us to see that here, like there is no one saying that it's about capacity. Like clearly the capacity is here. And so these implementing agencies probably that are present at this meeting are ready to go. And there's an issue with funding and opposition from other stakeholders. So finally, this last question we have is about how interested you are to receive more tailored support for the interpretation of the results of the Weplan-Forests. So as I mentioned, there is this possibility in the portfolio of actions of the Forest Ecosystem Restoration Initiative this year to provide support to a limited number of countries, because we won't be able to attend all the demand, but we really want to put that possibility out there. So if you have an interest, please let us know. I mean, you can also write to me or to Brooke or Marina at IIS. We'll share the emails afterwards, I'm sure. And we can explore, how to best approach that collaboration. Great, so it's nice to see that there's a high or very high interest, and we'll follow up on these results, and hopefully we can work with you towards the application of this of these solutions. Is this the last question we had? Oh, now we're seeing yeah. So in terms of the stakeholder groups, we're back to the first questions for which we didn't see the results. So, okay, so interesting. It's more varied than I had imagined, but there's quite a few people from academia or research. And the other one that we hadn't seen is about the type of information. And I think here there's an overwhelming call for more maps, clearly. So that would be the most relevant to decision-making processes. All right. Oh, no, we still have, the result was on the type of question. Yeah, I think we commented on that result before, actually. So I think we've reviewed all the questions and all the results now.
Okay, so it's done.
Thanks to all for your participation. Okay. Thank you, Blaise, and thank you all for your active participation in this poll. I've seen some interesting results in the answers, like also Blaise was mentioning. So I also saw a very high interest in terms of mapping and interest of support to actually use this decision support platform at country level. So first of all, I would like to thank the presenters for the enlightening presentations, and also for all of your active participation and contribution and questions. We heard during the first presentation from Robin that there is a huge potential for natural regeneration as one of the components of forest landscape restoration. If we take into consideration socio-economic context, of course. And I'll personally look forward for the updated version of the Weplan-Forest, integrating the natural regeneration into their platform, and also that's here the results and analyzers, of course. We also heard that optimization of decision making is hugely complex, and thanks to IIS and the support of CPD and KFS, we now have a tool that can help us to strategically plan for FLR both a global and national and also a local level. So I really appreciate the efforts and the potential for this tool for our countries and stakeholders to really plan for restoration interventions. Here on the screen again, you see the contact list. If you are interested to know more, to get some additional information, and also to request support potentially for using this tool and capacity building on tool. So we thank you all for your participation. We also have a short request for you, linked to the UN Decade on Ecosystem Restoration. They launched recently a global online survey to take stock of global capacity for ecosystem restoration, to identify whose capacity need to be enhanced to achieve the goals of the decade. So this survey is available in a variety of languages and open until the 15th of April. So we welcome your feedback and sharing of this survey with your networks. Thanks again for everyone for your participation. We remain available for any follow-up questions regards to email or to our D group, was posted in the chat. And we also share with you all the recording and the presentations accordingly. Thank you very much and have a good day further.
Thank you, Benjamin, for facilitating this meeting.
Thank
Thank
you.
you, everyone.
Bye.
Thank you.
Thank you. Bye-bye.